In this lesson, we're going to look at how we can use some of the techniques from the last lesson to verify whether some other statements are in fact identities or whether they are not. So, just a bit of review. An expression. There is no equal sign, and that would be something like sine theta plus 1. Sine theta plus 1 is an expression. If we want to multiply it by like sine theta minus 1, we also would have to create a denominator for a fraction and multiply by sine theta minus 1 because we don't have, quote, both sides of an equation to multiply by. Okay, an equation. So an equation is something like 3x equals 6 or sine theta equals 1. So an equation is true for specific values of variables. And that's what we would call an equation. So an identity is something like x plus 1 equals 2x plus 2 divided by 2. Okay, or tan theta equals sine theta over cosine theta. So the difference between an identity and an equation both have an equal sign, but the big difference is that for an identity, it is true for all real values of the variable. So essentially, tan theta is sine theta over cosine theta no matter what theta is. And that's the thing that we are going to be showing. So when we're verifying identities, what we want to show is that the identity is the same. And we can do that using some other identities. So let's look at how we might do that. Example 1. Prove that cosecant squared theta minus 1 over cosecant squared theta equals cosine squared of theta. Okay, so we want to prove that those two things are the same. So what we're going to do is we are going to take the two sides and we're going to put kind of a line between them. So I'm going to look at each side on its own, and I'm going to try to show that these two sides have to be the same. Okay, so I've got, and I can work with one side or I can work with the other. I can kind of go back and forth, but I'm trying to manipulate it, each side algebraically by itself. So we don't want to leave that equal sign in the middle because we don't want to be doing the same thing to both sides. What we want to do is show that both sides are the same. So here I have cosecant squared minus 1 over cosecant squared theta. So what I'm going to do is I'm going to separate. I'm going to try to make the left-hand side look like the right-hand side. I'm going to separate this into two fractions. So sometimes, and the thing about verifying identities that can be a little tricky is that you don't always know what the right way to start is. I also could have tried replacing cosecant theta with 1 over sine squared theta. I chose not to do that because I didn't feel like introducing a bunch more fractions was going to be helpful. I was going to try to simplify first because I also noticed that if I split this into two fractions, I could divide. But a lot of this is going to be developing instincts and just trying things, and make sure you do this in pencil because you may have to erase and go back, and that's okay. So cosecant squared theta, for cosecant squared theta, we get 1 minus 1 over cosecant squared theta. Remember, back to our reciprocal identities, the reciprocal of cosecant is sine. So 1 over cosecant squared is just the same as sine squared theta. Okay, because 1 over is just like not doing anything at all. So 1 minus sine squared theta is in fact, based on our Pythagorean identity, cosine squared theta. Okay, so now we've shown that these two things are the same, so the identity is verified. Let's take a look at another one. I can show you example after example, and it still won't necessarily tell you how to do the third problem. So a lot of this is just going to be you trying it on your own. So we're going to prove that cosecant x plus cotangent x equals sine x over 1 minus cosine x. So when we're proving these identities, your workbook actually has a pretty good set of what are some of the things you might try. So let's just make a list of a few of these things we might try. So we might, one, try replacing all trig functions with sine and cosine. So you can try rewriting things like cosecant and secant using their sine and cosine equivalents. Okay. You can simplify fractions. And simplifying fractions might mean taking two fractions with different denominators and adding them together, or it could mean taking a denominator and separating it out. So examples of how you might simplify a fraction. If you have like a plus b over a plus c over b, that can be written as a over b plus c over b. Okay? Or if you have two fractions with different denominators like a over c plus b over d, you might try finding a common denominator equals AD plus BC over CD. So you might try finding a common denominator and adding them together. There's not a particular direction that makes things simpler 100% of the time. It really depends on your problem. Okay, so number 3, which we're going to be using in this case, we're going to be multiplying by the conjugate. And we have to be careful. That has to happen in numerator and denominator, because we're not working with equations here for identities. Denominator. I can spell that word. Yay me. Okay. So these are 3 things that you can do to try to manipulate and simplify your equations. But to be fair, sometimes you will get stuck, and that's okay too. Okay. Part of what we need to develop is the ability to see where a particular identity might be useful. And part of that is just having a sheet in front of you and also getting to know your identities a bit. You will be allowed a formula sheet for this test. However, you want to be able to see the Pythagorean identity happening. You want to be able to see, oh, there's a 1 minus cosine squared. I know that's the same as sine squared. Or you want to be able to see, oh, there's a sine squared plus cosine squared. That equals 1. And if you're not at least somewhat familiar with it, you don't pick it out of the problem. And that's what you really need to work on, so that you'll be able to pick it out and see that that's going to be a useful thing to use. And same with some of your other identities. If you don't see a sine over cosine and recognize that that's a tangent, it's going to be tricky to do some of the problems. Okay, so let's take our identity that we're trying to verify. The nice thing about verifying identities is you don't necessarily have to take one side and get it all the way to be the other side. What you can do is you can manipulate the one side, manipulate the other side, and then show that your results get to the same thing. And that's what we're going to do in this circumstance. So we have cosecant x plus cotangent x, and here we have sine x over 1 minus cosine x. Okay, so cosecant x, I'm going to try on the left-hand side. We'll manipulate it. I'm going to try rewriting everything using sine and cosine. So I've got 1 over sine x plus cosine x over sine x. So these actually have the same denominator. So I'm going to try, and I see we have a single denominator thing over here. So I'm going to try writing this as 1 plus cosine x over sine x. And for now, that looks about as simple as I can get it. So I'm going to leave it, and I'm going to go play around with the other side. So here I have a 1 minus cosine x in the denominator. I notice my left-hand side has some similarities about it, but there's something in the numerator instead. So it has a single term in the denominator. So what I'm going to do is I'm actually going to try multiplying by 1 plus cosine x. I'm going to do that up here too. I have to, when we're doing a multiplying by the conjugate, we have to do it for the numerator and the denominator. So again, like last time, multiplying by the conjugate will often get me, when you're using sine and cosine, it will often get you to something you can use the Pythagorean identity on. So that's a useful one. So this gives me sine x over 1 plus cosine x in the numerator. And in the denominator, I get 1 minus cosine squared of x. So now I notice my Pythagorean identity. And so this is where I said you want to be able to see the Pythagorean identity in all its forms. So we know that sine squared theta plus cosine squared theta equals 1, but that also means 1 minus sine squared theta equals cosine squared theta, and 1 minus cosine squared theta equals sine squared theta. So identities are still identities if you manipulate what side the different variables are on. So the one I see here is I see a 1 minus cosine squared theta. So I can replace that with a sine squared theta, and that's a single term. I have sine x times 1 plus cosine x all over sine squared x. And now I can cancel one of my sines, and that gets me to 1 plus cosine x over sine x. And I can see here that this and this are the same. And because these are identical, we know that the identity is there verified. Okay, so what have we shown? We have shown that cosecant x plus cotangent x is the same as sine x over 1 minus cosine x. So this is the unit where your algebraic reckoning is going to come. If you have trouble with dealing with algebraic fractions, you need to sort that out before you're going to be able to deal with algebraic fractions with trigonometric functions. If you have difficulty with substitution or factoring, if you have trouble doing it for x's, you're going to have a lot of trouble doing it for sine x's and cosine x's and tan x's. So you need to make sure that you sort your algebra out, because this is the biggest problem that I always see in this unit, is people who don't have their algebra sorted. Okay, so as I said, the best way to really cement this is just to practice. So all those workbook questions, all the in-class questions, try as many different ones as you can so you can start to develop the instincts about what might work. And be aware that your wrong turns don't necessarily mean you can't solve the problem. It just might be that you need to turn around and try something else.